I'm working on this read it later Haskell app demo toy project, and I've finally gotten the database layer hooked up. I'm using Haskell for the database layer, and I made a little job queue. And then the last thing I did was successfully look up a job in the queue, act upon it, in which in this case is fetching a page from a URL, and then marking the job as complete. I'd like to move on to, now that this is at least moving around a little bit, I'd like to move on to adding RPC listeners and working on the front end just a little bit, but I don't think I'm going to get there today. I think today I want to just start cleaning up what I have, because I've coded it all in this pretty chaotic style where a lot of the functionality is in these test files, and the nothing about I'll just say nothing about it is ideal. So I think I'm just going to start by refactoring a little bit, and in the process of refactoring, I'll probably change some of the behavior as well. And one more thing that I haven't really done yet is I haven't tested a failing test case. So the test cases I'm looking at now, I'm always able to fetch the job, the URL, and I'm like printing out errors if an error occurs. But I don't know that my error handling logic is correct, because I'm not really testing the error case. I think I've decided that I want I'm going to assume that the wget will retry retriable errors. For example, if wget is trying to download some page and the page says essentially to back off, or give some indication that there is a retriable failure, I'm going to assume that I can call wget in a way that wget will retry those. Right now, I'm not actually doing that, but in the future, the intention is to replace wget with a real fetcher or crawler, maybe one like I think it's called Heritrix or something along those lines, the archive.org one, and just adding error handling for retriable errors and getting that right is a little bit fidgety. So I'd prefer not to have to do that. I think it's reasonable to assume that the crawler will handle retrying things it can retry, and similarly for backing off appropriately. So that simplifies things a bit. That means that really the only failure cases I have to consider are ones where essentially the user has done things like asked for a page that doesn't exist. So a 404, one where the user is unauthenticated and has requested, for example, a paywalled content, and situations where the crawler is rejected by robots.txt. And I think for each of those, there's not much I can do other than notify the user that an error has occurred. And the way that I assume that I should do that is store in the database the reason for the failure. I could do it as an HTTP status code, but I think what I'm going to do is just plop a status proto in the database, and maybe just for searching, also have a also insert the status code if there is one. And but we're not there yet. So let's start by just adding a failing test case, I guess. What's the easiest way to do that? Well, we have these two integration tests that have pretty overlapping concerns. And I've been promising myself and others that I would move to a real test framework. So I think that maybe what I'll do is I'll start trying to move some of this to a test framework. In the process, I will take these two files. The one's called SQL integration test and one's called SQL wget integration test. I'll take those two files, merge what needs to be merged, throw away what I can, and add anything that I guess needs to be added. And then we'll be just in a more rational place for moving forward. They do have a working invocation of the tasty test framework here, which I think I just copied from online. And I need to figure out how and if Tasty will let me run tests that do I/O, which I think it should. I think it does. But I'll figure that out. Maybe I can open the Tasty framework. Tasty test Haskell. We have tasty ingredients. Run tests in parallel, but report results in a deterministic order. So filter the test using patterns specified on the command line. Command line, hierarchical, color display of test result, reporting of test statistics, and acquire and release resources. Now that I'm thinking about this, I wonder if there should be no dependency on Haskell rules on any particular test framework. But let me see if they use anything, because there might be integrations between Bazel and other things. So they're using Tasty. I wonder if they use HUnit as well. There's some HUnit stuff, but it's like Tasty HUnit. Okay, so I'm going to assume that Tasty is fine. Acquire and release resources. So this seems to imply that you can do some I/O since it has sockets and files. Extensibility. And how does it work? I guess test tree is maybe fundamental. Tests is a thing that returns type test tree. It's calling test group. On string tests, I'm guessing this string is maybe just the human readable name. It's passing in a list. The list is maybe some list of tests, property tests and unit tests, I guess. And somehow this defines a tree. I guess maybe these are the leaves of the tree. The test is the name, and the test group is perhaps the kind of tree. And then we have properties, which is also a type test tree. And these are prop tests, SC prop and QC prop. And then SC props, to define them, we get a human readable string as the second argument for all of these, I bet. And a test group, whatever this is called, I guess like I don't know if this is considered a kind of constructor. But I guess we're not really constructing anything. We're actually just running a function, right? So, well, we kind of are. At any rate, the third thing we pass it, the second thing we pass in test group, other than this string, is a list, just like here. And in this case, the list are functions. And we're calling this function scTest property with some stuff. And here, the lists are other test groups. So I guess this is like the tree behavior. Let's find this test group thing. So a test group is a thing that takes a test name a list of test trees and returns a test tree. So then what is a test tree? It consists of individual test cases and properties organized in named group which form a tree-like hierarchy. Do we not, is it just a, okay, we get this for all. For all t, if, I guess, I'm not really sure how to read for alls in Haskell. For all t, if, I guess this means if t is a test, is test t, then I guess this is saying the type is single test, test name t, a single test of some particular type. Or it's a test group, test name, test tree, which is the case that of I guess these up here. And these are the list of single tests. Or it's some plus test options. Or it might be something with resource. It might be ask options, ask for the options and customize the test based on them, etc. I don't know why. I don't know if this case covers the list case. No, I guess this does. And then I guess this covers the same case. And then once we look inside the list, we get to the single test. But just for fun, let's look up Haskell for all. I'm beginning to understand how the for all keyword is used in so-called existential types like this. Data show box for all s, show s. I guess this is like some constraint, right? If show s really, then s be of s. I find people trying to explain Haskell are often what's the word? Not so clear. So it's for working with polymorphism. Okay. Polymorphic functions can work with different types of data. For example, the identity function from A to A takes any type A and returns the same type A. For all, an explicit quantification. By default, polymorphism in Haskell is implicit. For all lets you explicitly state type variables for better clarity or with certain extensions. For example, for all A to A is the same as just ID from A to A. So it's just making it explicit. Why use for all? It's not essential in vanilla Haskell without extensions. It becomes useful with extensions like rank n types or for advanced type level programming. Okay, you can improve readability by making type variable scope explicit. It's usually used with type signatures, not bodies. Is rank n types like a promotion to a higher kinded type? Normal Haskell, 98 types are considered rank 1 types, such as A to B to A implies that the type variables are universally quantified, like so. For all A, B, A to B to A. For all can be floated out of the right-hand side of arrow, if it appears there. So for all A, A goes to for all B, B to A. So it's kind of like lambdaizing. This is also a rank 1 type because it's equivalent to the previous signature. However, one on the left-hand side cannot be moved up. And then there's another, so therefore forms another level or rank. Appearing within the left-hand side. So for all A to A, 2 for all B to B, can't be moved. This is a rank 2 type because the latter for all can be moved to the start, but the former one cannot. Therefore, there are 2 levels of universal quantification. All right. Rank 2 or rank n types may be specifically enabled by the language extension. Okay. So this is like this is for enabling higher ranked types, where rank is something about the layers of nesting of for alls that you can't move past each other, or something along those lines. At any rate, we'll see if we can create some tests, some tasty tests. And I don't really have any idea how to do this. I'll ask the AIs. Write a tasty Haskell test that prints to the command line. I guess there's is there just no limit to doing that? No. So let's try, first of all, I want to see what it does if I have 2 tests with the same name. Okay, so I didn't like that list. So this is some list. What am I doing wrong? Maybe I just need some. Okay, I don't know what I had done wrong before, but so it doesn't seem to have any problem with 2 tests being named exactly the same thing. Okay, so let's just try adding a 3rd test that does some IO. It probably needs to return a bool. So couldn't match expected test type. Expected type test tree with actual type IO. Okay, so it does IO and it doesn't like that. So how about I do test case? Nothing. And then I guess to do a test case, I need to have something. Let's find on Hoogle. The test case function. Test case takes a test name and an assertion. Turn an assertion into a tasty test case. So an assertion has type IO of whatever. IO of nothing. It's simply an IO action. Assertion failure is indicated by throwing an exception, typically H unit failure. Okay, so and then we need we have this like @ question mark thing, and we have compare. So compare is, I'm going to guess, Just like an alias for equals or something. Maybe compare is built in. Okay, and then whatever this is. I don't know if I can search Google for this sort of thing. Yo, ordinary tranquil. How's it going? Okay, so we have, this is a thing, it's from HUnit. And it's a thing that takes an A and an A and makes an assertion. And I'm going to guess it's like, is this equal to, I don't know what else this could be. Asserts that the specified actual value is equal to the expected value with the actual value on the left-hand side. So this is the actual value. Here's the expected value. I'm doing good. Doing well. Okay. So what else can I do? We have a few other infixes. A value, let's see. This is equals. This is a flipped version of assert bool. I'm not sure what assert bool is. Assert equal. So how is assert equal different from this thing? They have it takes a string that has a message prefix. The output message will contain the prefix, the expected value. Huh. Okay. And then assert bool is kind of the same thing. So here's an example of assert bool. Assert bool non-empty list null 1. And then this, for whatever reason, this flips it. So null 1 non-empty list. I don't know why. I'm not really sure why flipping it is important. Are these the only assertions we have? So where can I sneak in a, how about we do this? Add some numbers. Wait. So where does the IO come in? So test case has some IO action, right? So test case takes a test name and an assertion and returns a test tree. So here's the test name. So I guess this is the assertion. But why is it, I guess I don't see where the IO comes in. Let's take a look at assert bool. Instead of throwing the exception directly, you should use functions like assert failure and assert bool. I don't really know how, so Haskell throw exceptions. So an exception, I guess, so try, if E is an exception, it does IO of A and returns IO of either exception or A. Is that the kind of exception we're talking about? Maybe. Maybe we can look at the source code of assert bool. Assert bool uses assert equals. Okay, so assert equal has this assert failure message where location maybe source lock. Call stack H unit failure is an instance of E exception. Okay. And it calls the display exception. All right, I don't know really what any of this means, but let's try. So this should be equivalent to calling compare compare in the first on the left side, right? Okay, and really, if I feel like this only has 2 arguments. So how is it returning a test tree? What if I just give it an assertion? So I'll call this test case foo, and then we'll just have an IO action. So it seems to say that's okay, and in fact, it actually, the thing that I print out is like what it puts on the test. So if I say you are the greatest. Okay. Well, so how do I get it to fail? I have to somehow like raise an exception, which I do not know how to do. Although I do. So fail a H unit test. A tasty. I think I saw somewhere earlier, just like at the beginning of this stream. Assert failure. Unconditionally signal that a failure has occurred. So if I do assert failure, which I probably have to import. So I can use pfoo to rerun this test only. Okay, so I guess I don't need to import that separately. Okay, so assert failure stands in where previously I was I was calling exit failure. And I don't ever need to call exit success. That's fine. So let's try moving some stuff over. Or do I really want to move it over, or do I just want to make this into an HUnit thing? This is a good question. One thing I could do is I can make this the SQL integration test module and import qualified SQL integration test. There's no need to do IO. Let me just comment this out. Oh, ordinary tranquil. I just realized that I think you were talking about Hugel. I thought at the time you were saying something about Emacs. But yeah, Hugel is super cool. This is the ability to search by types in a useful way. I realize that LSP can kind of do that. But where did Hugel go? I feel like it's its own thing. Just like you know, you have a function that takes a list. You have a function that takes a singleton, let's say, and you want to return a list of it. You can find all the things that can do that. I think that's really useful. I don't really know how you would do that outside of Haskell. I'm sure there's something similar somewhere. Okay, what was I doing? I was trying to find the build file. So SQL integration test. Oh yeah, I said it was a test, which I guess it is. I could say it's a library. And I don't know if Rules Haskell supports this. You remember how Bazel goes Bazel test only. I don't know if this is actually going to work. So I'll say that this is also a test-only library. So that test-only will make it so that I can't import. In theory, assuming Rules Haskell supports it, test-only means that I can't use this library anywhere except test. If I try to import it from something that I'm going to use in production, then Bazel will refuse. Let's see if this mentions test-only. Actually, I don't think that the Haskell rules really has to support it. But maybe Haskell binary and Haskell test need to know about it. They seem to at least know about it. So that's good. Okay. So let's just start by the things that I was doing in here. I also need this database string, which I would like to start being a responsible person and not just hard coding the password. Let's see if I can do that. Tasty HUnit. Oh, okay. Yeah, that's just like I don't know what that's called. Is that hackage? But yeah, that is pretty cool too, actually. It's like the Haskell documentation. And you can click in the source. And this is good. Hackage, I guess, is what it's part of. You can't really do this with, with Python, I think. Python's types are getting slightly better, but it's still a very stringy language. Yeah, command line parsing. Parse the command line arguments. Okay. But what are the command line arguments? I guess it means by command line arguments the arguments to the test framework, like which tests to run. I think that I think Postgres will just try to just let me auto populate the string, if I remember correctly. So why don't I just copy this over for now, and I think that I can just remove the user and whatchamacallit and just populate shell like environment variables. Is that true? I don't know. We'll find out. Okay, and then the actual recipe for what I was doing is this stuff. And how are we going to do this? Yeah, I tried. This is my first time really learning Haskell. I've looked at it before, but this is my first time like actually trying to legitimately build something with it. So far, I like it. It's a nice language to work in. Modulo, some of the tools are not as well developed and well polished as some other programming environments. So can I just take this? Well, no. So these are now doing just I/O, right? Yeah, these are just doing I/O. I have to release the connection somehow, somewhere. Maybe I could do that with resources. And here, other than release the connection, I can do test. Hey, test group. And I'm calling exit failure, which is maybe going to do what I want and maybe is not, but that's fine. I'm going to guess that I don't know how hard it is going to use this with resource thing. Tasty with resource. There's no way to do it in a cleanup function. If and only if freed, if and only if the assertion is passed. That's not what I want. Actually, maybe I should look up what Haskell does, because they might use tasty. They do. All right, so they have their test tree is very advanced and large. So they have a bunch of different test cases. So test group, all tests, and here's the left bracket. Test group round trip is, I guess, just this. This is just one group, and then I guess this is a specific case. And they're getting a connection here. Connection.with. Let's see where we can find out about connections. Unsafe perform IO do. I don't know what connection with does, but it kind of looks like they're using a different connection for each statement. Is that what I should be doing? So I think that they run their test on localhost. So here's their connection. I see. So with is a thing that takes an HC connection going to IOA and turns it into a IO of either HC connection error or A. This is too fancy for me. I guess that I think that's they're calling connection with each time, that they are using a different connection for every call to the database. Is that what I want to do? So we'll ask ChatGPT, in my unit test, should I reuse the database connection or create a new one for each test, for my integration test? Okay, yeah, that makes sense. Just for isolation, sure. Okay, so in that case, I don't need to, well, in that case, I need to release each connection. And I guess I need to add to each of these the connection release logic. And it makes sense why you would want to not do that each time, because it's a little bit annoying. You want to make sure you don't forget it. So, but I don't think that this style here, well, maybe it does. So what happens? Where does the connection get released? Okay, so release connection, use connection. So run except T. So except T, I think, is a way of like kind of combining the either or except monad with some other monad. And maybe in this case, this combination of IO and either is what's going on. And what it's doing, I guess, is it's saying acquire, somehow acquire the connection, use the connection, and then release the connection. where use connection is going to call lift on handler connection. And I'm not sure really with is called with handler. And then again, I'm guessing the handler is the thing that changes. Something along these lines. Conceptually, that's what's going on. So connection with session.run session. So session.run session, I'm guessing, is the handler. And assuming that's more or less what's going on, that's kind of conceptually reasonable, but it's also, I want to err on the side of repeating myself and having readable code over having fancier code, because I'm certainly not a Haskell developer yet, and I want the code to be somewhat readable and usable by people who are not advanced Haskell people. And I know that the guy who wrote Nikita, the guy that wrote Haskell, is seems to be very strong and has a does it professionally. So I'm not there yet. So I'm going to do the more repeat myself version, which I'm just going to pepper release connection into each of these functions, and hopefully that'll work. I'll have to do it before I exit failure, I believe. But that'll be fine. I should also install a some sort of tool to format things consistently and to do linting. First of all, these will need a do, right? So okay, that should be fine. So I told it I wanted this to be a library, but let's undo that. I don't know if it will still allow me to do test only, but I think I could run Bazel test here. So it doesn't like that I made this change and then I didn't change something else about the rule for the wget test. That's fine. Okay, so when I try that, it fails, and I think it's failing because I changed the module. So let's unchange the module. All right, so now we're getting a failure. Connection pointer is null. So somehow I have destroyed my pointer, my connection, which is not surprising. Oh, it's because, yeah, okay, so it's because I released, it's because I released the connection, and I tried to use it everywhere. So I can't do that. So what I have to do is take this construction, I have to do a bunch of left rights, I guess. which is ugly. I do see the appeal of having the alternative construction where there's this like the accept T monad thing. Okay, but at any rate, where if I consistently do the connection properly, this ends up being fine. And in fact, I think I can just take this whole construction and call it run with connection con func. No, I can't because I have to pass in different things. Yeah, I can. Let's try this again without deleting that. I don't think I like this though. So I'm going to have to pass in a lambda. So I can do like run with con. And it will take a connection. And a func. And then I can rewrite one of these as, first of all, I don't have to keep doing this let connection string thing. Oh, yeah. Okay, so I can do that. I have this like run with connection thing. That is maybe acceptable. That's maybe not acceptable. I was planning to get farther, but I think I'm going to take a break here and come back to this perhaps tomorrow. But at least I have a sense of what I can do. And I think I'm on my way to cleaning up what I came into this thinking was a gigantic mess. I think will not be as bad as I thought it would be.